I'm going to walk you through the process of conducting a sensitivity analysis. I'm going to make some assumptions about some numbers and just show you mechanically how you would calculate the expected value, which represents the full range of possible outcomes. So we're going to focus on 3 scenarios in this example. You could do more, but for simplicity's sake, we're going to do 3. We're going to do the most likely case, which is the initial set of assumptions. And then we will do the best case, which is what the best that you could expect to happen. And then we will also do the worst case, which would be the worst that you could expect to happen. And what you would then do is for each one of those cases, based on your assumptions, you would then calculate the NPV, the ROI, and determine the payback for each one of those particular cases. And once you did that, once you have 3 sets, in this case, of net present values, return on investments, and payback, then you would assign a probability. And for the sake of this exercise, I'm going to assume that the most likely probability is 60%. I'm going to assume the best case probability is 10%, and I'm going to assume the worst case probability is 30%. And we'll walk through how you would do the calculations using some example numbers. Now, one thing that I would like to say here is notice this distribution. The fact of the matter is, in the real world, the worst case has a higher probability normally than the best case. It's just the way things work that things have a higher probability of going wrong than of actually working out perfectly. But we will calculate a full range of possible outcomes assuming this probability distribution. So then let's crunch some numbers. What you do is you start to calculate what we call expected value. It's a fancy name for what is also known in mathematics is a weighted average. What I did here is, for our most likely case, I put in the $795,000 NPV, the 299% return on investment, and the 1-year payback. I actually then put in the best case, which is $900 for NPV, 400% ROI, half a year. And then in the worst case, I come up with my calculations based on my assumptions, $400,000 NPV, 120% return on investment, and a 2.5-year payback. Next step is that I then take each case, the most likely is the first one, and I multiply the probability by each of the initial amounts. So I take the 60%, multiply it by the 795, come up with a weighted outcome of $477,000. I apply that 60%, multiply that 60% by the 299% ROI, come up with 179%. And then I take that 1-year payback, I multiply that by 60%, and I come up with 0.6. And then I do the same thing with the best case. I take the 10% probability, multiply it by the $900,000, come up with $90,000. Apply that to the ROI of 400% and come up with 40%. And multiply the 0.5 payback, the 6-month payback in this case, and come up with 0.05 in terms of my weighted outcome. I apply that 30% to each of my net present value, ROI, and payback. So 30% times 400 is 120,000. 30% times 120% is 36%. And then 30% times 2.5 is 0.75 is the weighted outcome. And then what I do is I sum each one of these weighted outcomes, and I come up with a total of $687,000 for a weighted outcome of net present value, 255% return on investment, and a 1.4-year payback. Those numbers are your expected values. That, in a single number, in each one of these cases, you have accounted for the full range of possibilities. Like I said before, when your boss says, "What's the return going to be?" you don't say, "Well, it could be as good as 400%, or it could be bad as 120%, but it may be somewhere in the middle of 299%. That sounds not only wishy-washy, each one of those individual numbers are probably not accurate either. However, that expected value number is your best chance of what truly is going to happen, provided that you're right with your assumptions within that range and probability. And the other beauty of the sensitivity analysis is, and you can do this easily in Excel, is besides changing the initial assumptions that drove each one of these numbers, I can change this probability. So I might say, you know, that worst case may be a better chance of happening than I thought. Maybe I'll bump that up to 35% or maybe even 40%, and I can drop my most likely down to 55 or 50% and see what the effect is. Each one of these represents in a single number the full range of possibilities. And when I ask you, or when you put in your executive summary, your net present value and your return on investment and your payback, these are the numbers that I would expect to see. So it's these expected values that you should put in your executive summary. So there you have it. That's how we would mechanically go about calculating the expected value, which is the end result of the sensitivity analysis. Again, the expected value represents the full range of possible outcomes, and that gives you the hedge that you would need in the face of uncertainty.